Hello friends and welcome to Zonadiscgolf. We have already seen the chapters dedicated to the flight of the disc, the 4 flight numbers, and now we are going to see some advanced chapters about other things that influence the flight of our disc. The first of them is air density. The air weights, it has some actual weight. 1,000 liter container has inside 1.2 kilos of air. So if you make the vacuum, it will be 1.2 kilos lighter. It has some actual weight. There is a curiosity that the air contained inside the Eiffel Tower in Paris is heavier than the Eiffel Tower. It seems strange, but it's absolutely true. So the air has some weight on it. Of course, the density is quite small. When we walk on the street, we don't really feel the air density because we are walking very slow. Although if we walk on a swimming pool, we feel, of course, the density of the water because it's almost 1,000 times more dense than the air. What does influence the air density? There are 3 variables, which are the altitude, which are the temperature, and the relative humidity. Okay, first of them is the altitude. The air in the atmosphere is disposed in a number of layers, so of course the upper layers are compressing the lower layers because the air is slightly compressible, and the lower layers have higher density than the higher levels. If the air density at sea level is 1.2 kilos, approximately every 1,000 meters that you gain, the air density reduces by more or less 10%. So if you play at sea level, like here in Bilbao, in the Basque Country, and then I go running to Madrid, to the Sierra at 2,000 meters, and I start playing there, the air density is 20% lower. So what will I feel? I will feel that all the aerodynamic forces are smaller. I have already tried it with some drivers that I know quite well, and if I throw at 2,000 meters on a parking lot on the ski station in the summer, I feel that the air doesn't slow down my disc is very fast, but on the same time it falls to the ground quite fast because there is 20% less lift. The disc doesn't fly that much. Okay, so what I have to do is maybe aiming a little bit higher to compensate for it, because otherwise I will fall very fast to the ground. And I also feel that the disc tends to act more overstable. Why? Because as we saw, the turn and the feint are caused by the lift, by the gyroscopic precession applied to the lift force. But when we throw, the turn is applied on the first part of the flight, the high speed stability, and its effect seems smaller because the disc is traveling faster. But when the disc is slowing down, the feint seems to have a higher effect because the disc is traveling slower. So the combined effect of losing air density on those 2 effects is that it seems like that when the air is thinner, the disc acts more overstable because the loss on the feint is less important than the loss on the turn. So we gotta help the turn a little bit, usually by choosing a disc that is slightly more understable than what we would throw at sea level. So if I usually throw a -1 turn, maybe I will throw a -2 turn to help it a little bit on this aspect. Okay, so we have seen that as we gain altitude, we lose air density. If we go to Colorado at 3,000 meters above sea level, the loss of density will be something like a 30%, so it will be quite a heavy effect. There are more variables. The second of them is the temperature. The hot air is less dense than the cold air. That is why the hot air balloons fly. If we fill a balloon with hot air, it's lighter than the air that it's surrounding, so it floats on the air, and that is why the hot air balloons fly. if we raise temperature by 6 degrees, the air density gets reduced by more or less 2.5%. Okay, so we can read this two ways. First of all, if we play on our local course, and we're used to play in the summer at 30 degrees, and then we play in the winter at 0 degrees centigrade, there is a 30 degrees difference. So it's if every 6 degrees is 2.5%, that will be something more or less like 12.5%. The air will be more dense when playing cold. So I would feel that if I'm used to play in the summer and then I play in the winter 30 degrees lower, I feel that the air drag is higher, my discs are not as fast. I feel that the lift is higher, the glide is also higher, my disc tends to fly a lot, and I also feel that the turn and the fade are modified. The turn effect feels like a little bit more prominent than the fade effect, so that is why if I play in the winter with a more dense air, I would choose a more overstable disc to compensate for this. And the opposite is true. If I play in the winter at 0 degrees and then I play in the summer at 30 degrees, I will feel that the air is thinner, my disc is faster, but it has less glide, and I gotta help the turn more than that I gotta help the fade. So gaining 30 degrees of temperature, it's 12.5% of air density loss. So it's more or less like if I play 1200 meters higher than the sea level, more or less. There is another variable, which is the correlation between the altitude and the temperature. We say that if we go from sea level to 2000 meters, we lose around 20% of the air density. But it's also true that when we gain altitude, we also usually lose temperature. The average is more or less like 6 degrees every 1000 meters. So if we gain 2000 meters, we should lose more or less 12 degrees. Mountains are colder than sea level usually. So if we go from 0 to 2000, we will lose 20% of air density, but at the same time, as we lose 12 degrees of temperature, we will have an air 5% thicker because of the loss of temperature. So we lose 20% of density, but we gain 5%. So if we sum it, we lose 15%. So that means that when you gain altitude, it's true that you lose air density because of the altitude, but it's also true that you gain air density because of the loss of temperature. But the air temperature is not as heavy effect as the altitude effect. And the third variable that influences the air density is the relative humidity. The air is a mix of gases. It has a lot of nitrogen, some oxygen, carbon dioxide, and one of them is water vapor. The water vapor is a bit counterintuitive, but water vapor is lighter than dry air. So if we mix dry air with a gas that is a bit lighter and we mix it, of course, the result is a bit lighter than the dry air. So as we add water vapor to the air, we diminish the air density. Of course, there is a point, the relative humidity, when it's 0%, there is no water vapor, and when it's 100% of relative humidity, it's not that we are underwater. It means that the air cannot accept more water vapor, because if you put more water vapor, it will condensate into liquid water. That it's called the dew point. If we change from 0% to 100% of relative humidity at 25 degrees Celsius of temperature, the air density reduces by more or less 2%. So the effect is quite small, it's the smallest of the three. As we gain temperature at 30 degrees, it will be something more like 3% of diminution. And the effects are bigger at 60 degrees, 70 degrees, 80 degrees. So it's not applicable to disc golf because we don't play at such temperatures, no? But it's true that when you gain relative humidity, the air gets a little bit thinner, but the effect is quite small. Okay, so if we play in a less dense air, so if we play at higher altitude, at higher temperature, and at higher relative humidity, the air will be thinner. So our disc will feel less aerodynamic drag, but it will also have less glide. It will be harder for it to fly, to go up, and it will have less turn and less fade, although the effect is more relevant on the fade. So we will have to add a little bit of turn to compensate for this, and maybe we will have to aim a little bit higher to compensate for the lack of glide. See ya in Zonadiscgolf.